Hello, another AQA A-level physics problem from the thermal physics topic. If you want to answer the question yourself, pause the video now. If you got the answer right, well done. So the diagram shows two flasks X and Y connected by a thin tube of negligible volume. The flasks contain an ideal gas. The volume of X is twice the volume of Y, and when X is at a temperature of 100 Kelvin and Y is at a temperature of 400 Kelvin, there is no net transfer of particles between the flask. X contains gas of mass M. What is the mass of gas in Y? So starting point for all these sorts of questions is to think about what sort of equation is going to help me. And the equation that's going to help me is the following, and that is that the pressure multiplied by the volume of a gas is equal to the number of moles multiplied by the molar gas constant and the temperature. Now I'm going to rearrange this in the following way, and I'll explain why in a second. So pressure multiplied by volume divided by number of moles and temperature equals molar gas constant, and as its name implies, it's a constant. So it says any gas, if you multiply the pressure by the volume, divide it by the number of moles and the temperature, will equal that same value every time. So I could say we've got two conditions here. We've got a gas in X and a gas in Y, but for both of them, if I multiply the pressure by the volume, divide it by the number of moles and the temperature, I'm going to get the same value. So I could say that the pressure in X multiplied by the volume in X over the number of moles in X and the temperature in X is going to equal to the pressure in Y, the volume in Y, the number of moles in Y, and the temperature in Y. Now you notice we're after mass, and I don't have mass in this equation, but what I do have is the number of moles, and the mass is going to be directly proportional to how many moles there are. So if I can find out how the number of moles changes, I've found out how the mass changes. Okay, so it's the number of moles in Y, or the mass in Y, that I'm interested in, so I can rearrange this equation and I can say the number of moles in Y is equal to the pressure in Y over the pressure in X multiplied by the volume in Y over the volume in X multiplied by the temperature in X over the temperature in Y. So let's just have a quick look here. In terms of the pressure, because these two flasks are connected, the pressure in both these flasks is going to be the same. So in terms of ratio, I forgot to add something to that. I should have multiplied all that by the number of moles in X. So let's put some numbers in here. So the pressure is the same, so I can say the ratio of pressures is the same. The volume says the volume in X is twice the volume of Y. So I can have 1 over 2 there, and it says the temperature of Y is 4 times the temperature of X. So if we put all that into our calculator, we discover that the number of moles of Y is equal to the number of moles of X over 8, and as I said, the number of moles is going to be directly proportional to the mass, therefore the answer is A. If you found this useful, click on that subscribe button please, share and like, and watch more in the series. Thank you for watching.